Okay, we're going to look at an exam type question. In fact, it is a question from an exam. It's Let's just read it. The first thing you should always do is read the story and look at the picture and make sure you got it right. It says in the diagram, O is the center of the circle. Well, there's O right there, right at the center. E is a midpoint of a chord AD. Midpoint of a chord AD. Um, AO and EO are produced. AO are produced. That means the line continues on. And EO are produced and they end up at C and B. And AD is produced. AD is produced and ends up at G here. Okay, and the line GC is a tangent to the circle. Okay, so O3, you're given that equals X. Now they say, why is EOCG a cyclic quadrilateral? Well, here's the reason. Let's take a look here. C3, this angle here, the tangent is perpendicular to the radius, so it's got to be 90 degrees. Now, E2 has to be 90 degrees. And the reason it is because it's a line from the center that goes to the midpoint of the chord. A line from the center that bisects the chord. Now in the notes, I think I called this I. It's EOG, therefore, is a cyclic quad because these two angles now, there's E2 and C3, they both equal 90 degrees. They add up to equal 180. And if the opposite angles of a cyclic quad add to 180, it means that, or of a quad add to 180, it means that that quadrilateral EOCG must be cyclic. Okay, so there it is. That's why it's a cyclic quad, because these, we just proved they were both 90 and they add up to 180. Okay, write down with reasons two other angles that equal X. Well, you've got these two lines that cross each other. O3 is X, so O1 is X. And that's an old idea. You should know that vertically opposite angles are equal. And then EOD must equal X too. Well, because this is a side, they both share an angle of 90 degrees and they have a common side here. So side angle side makes these two triangles congruent, which means these two angles, A3 and EOD must equal X. Okay. Well, let's see here. Express A1 in terms of X. Well, there's angle A1. It opens up to this chord, to this segment of the circle that's BC. But this is an angle from the center that's X. Well, the angle of the circumference is 1/2 of this angle, so it's X over 2. So A1 must be 1/2 of X, it must be X over 2. And the reason is the angle at the center is 2 times the angle at the circumference. Well, that's it. Let's go to the next question. You've got all this in the memo. I'm just sort of going through it, so hopefully it makes some sort of sense. Express C1 in terms of X. Well, let's find C1. Ooh, that's an angle between a tangent and the chord BC. Well, it opens up to this angle A1, subtends the same chord. There's the alternate angle there, A1. So that A1 must be the same as C1. And we just learned in the last question, A1 was X over 2. So C1 is X over 2. And what we're using is the tan chord theorem. The angle between the tangent and the chord is equal to that opposite alternate angle there, interior kind of angle. Okay, let's do the last question. Let's try and find C2 in terms of X. Well, we know that these angles B2 and C2 and X all add up to 180 degrees, okay, because angles sum in a triangle. So we know that's true. But we also know that these two sides here, OB and OC, are really the radius of this circle. And if that's true, B2 and C2 must be exactly the same. They must be exactly the same angle. So C2 and B2, it's like it's 2C2 there because they're both exactly the same thing. And why is that? Because equal angles are opposite equal radius, equal sides. Well, if two of these are equal to 180 minus x, all we do is divide by 2. 180 divided by 2 is 90, and we get x over 2. So angle C2 is 90 degrees minus x over 2. Well, we've got this memo all on in the answers to the questions that the exam questions we've done. Just maybe the memo will help you. I hope it does. Okay. And we'll do another memo of one of the proofs as well in a bit.